Hello there. In this video, we're going to go through the next section of the next chapter on the Rust programming language book that is starting Common Programming Concepts. This chapter covers concepts that appear in almost every programming language and how they work in Rust. Many programming languages have much in common at their core. None of the concepts presented in this chapter are unique to Rust, but we'll discuss some of them in the context of Rust and explain the conventions around using these concepts. Specifically, you'll learn about variables, basic types, functions, comments, and control flow. Yeah, I mean, every programming language that I've dabbled in, even just like a little bit of taking a look around at what the features are, you quickly realize there's a lot of things that are in most languages. So these foundations will be in every Rust program, and learning them early will give you a strong core to start with. Keywords. The Rust language has a set of keywords that are reserved for use by the language only, much as in any other language. Keep in mind that you cannot use these words as names of variables or functions. Much of the keywords have special meanings, and you'll be using them to do various tasks in your Rust programs. A few have no current functionality associated with them, but have been reserved for functionality that might be added to Rust in the future. You can find a list of the keywords in Appendix A. So I think that's kind of interesting. This is the first time I've seen like a documented list of keywords in a programming language that are definitely reserved for future. I think I've occasionally seen it maybe in Python with some Python enhancement proposals, but I'm not sure that all of the ones that I'm thinking of were actually accepted, or any of them. I'm not sure. But I feel like the Python enhancement proposals are they're all about what's in the future, whereas having a canonical list of keywords and going like, we don't know if or when, but these are reserved for future use is kind of interesting. Okay, we're going to do the first section in this video of this chapter, so variables and mutability. As mentioned in the storing values with variables section, by default, variables are immutable. I think that's a good idea. This is one of the many nudges Rust gives you to write your code in a way that takes advantage of the safety and easy concurrency that Rust offers. I guess immutability and concurrency are sometimes coupled in terms of, like mutable references to a shared memory object type of discussion. But I also think that the mutability part or immutability part can have some value, even if the goal isn't really to have concurrency, even if it's just you want to make sure that a value is what it is. I think that there's some value in that. Okay, so, however, you still have the option to make your variables mutable. Let's explore how and why Rust encourages you to favor immutability and why sometimes you might want to opt out. Yeah, sometimes you're going to want to opt out, but it's a good default. When a variable is immutable, once a value is bound to a name, you can't change that name. To illustrate this, generate a new project called variables in your project directory using the cargo new variables command. Let's do it right now. Cargo new variables. And let's go into variables. And let's open up our source main. So they want to show us an example here. Okay. Then, in your new variables directory, open the source main RS and replace its code with the following code, which won't compile just yet. All right, let's do it. Let's fill in whatever the code is that they want to fill in. So we got x is bound, let x be bound to the value of 5, and we're also declaring that x exists in that line with the let keyword. We're going to do print line macro, the value of x is, and then formatted. And then we'll assign x to be the value of 6. And then print line macro, the value of x is. Now remember, we're talking about in the context of immutability. We didn't use the mute keyword, so this should be immutable. And there, our compiler or our checker in our IDE here is using the check command to make sure that everything works, and you're already getting a hint here. Cannot assign twice to immutable variable x. Cannot assign twice to immutable variables. All right. So save and run the program, cargo run. You should receive an error message regarding an immutability error such as shown. Let's just open up another tab here and maybe zoom in a little bit. And go cargo run. And there's our compile error. Did we get the same compile error number? We got Error 0384. Yes, that's the same error. Cannot assign twice to immutable variable x. There's the first assignment, and then here's the second assignment. Cannot do a second assignment. So one of the things that the compiler is suggesting here is that we make x mutable by let mute x being declared. All right, what does the tutorial want us to do? This example shows how the compiler helps you find errors in your programs. Absolutely. Compiler errors can be frustrating, but really they only mean your program isn't safely doing what you want it to do yet. They do not mean that you're not a good programmer. It's like, is this to make somebody who's feeling a bit, tender about this feel a little bit better? Is that what this is? Experienced Rustaceans still get compiler errors. Sure. It's not only that it happens to the best of us type of thing, but I think that for a lot of coders, like incrementally writing something out, even though the steps along the way don't always like work now, is sometimes part of the feedback loop that they use to decide what to do next in building the program. I don't think that getting compiler errors or warnings and stuff like that is bad at all. It's not inherently bad. You want the final result to compile. That doesn't mean that the steps along the way always have to compile. You received the error message, cannot assign twice to mutable variable x, because you tried to assign a second value to the immutable x variable. We sure did. Okay, so it's important that we get compile time errors when we attempt to change a value that's designated as immutable, because this very situation can lead to bugs. Yeah. If one part of our code operates on the assumption that a value will never change, and another part of our code changes that value, it's possible that the first part of the code won't do what it was assigned to do. Yeah, absolutely. I mean, some of this is the beauty of immutable values, though, is to have some fixed knowns. It's not quite as strong as declaring constants, but, it's kind of the middle between constants and mutability, is to say this is definitely the thing that it's supposed to be, unless you use the let keyword to like shadow it, right? Okay, the cause of this kind of bug can be difficult to track down after the fact, especially when the second piece of code changes the value only sometimes. Yeah, that can get a little bit tricky, and when you're dealing with programs that interact with the real world, it's not even, you can't even detect everything through static analysis or even through doing dynamic analysis for rare events. If a rare event occurs, you may not have had the right tool set up, the logging and so forth, to get sufficient information about why something stopped working correctly when it did. It's hard. In the general case, it's hard. The Rust compiler guarantees that when you state that a value won't change, it really won't change. So you don't have to keep track of it yourself. Yep. Your code is thus easier to reason through. I feel like that's one of the benefits, like just even from reading the code, is going, I see that variable is not mutable. So I know that that's like a fixed known, at least until then, if or when it gets another let command that overrides it. So if I see it being passed into functions, but it's immutable, I know that it's not going to later on return that very same thing that's somehow different. It's immutable. Okay, but mutability can be very useful and make code more convenient to write. Yes, I agree. Although variables are immutable by default, you can make them mutable by adding the mute in front of the variable name, as you did in Chapter 2. That was the programming a guessing game. Adding mute also conveys intent to future readers of the code by indicating that other parts of the code will be changing this variable's value. Love it. Communication of intent. Ooh, this is actually a code snippet that runs. Let's run it. I mean, I did that, and then I just immediately felt bad where I'm like, well, hey now, why don't we just put that little mute in our program ourselves, and then we can run it, and we'll get the same result. That feels pretty good. Okay. Now, when we run the program, we will get this result. We did get that result. We are allowed to change the value bound to x from 5 to 6 when mute is used. Ultimately, deciding whether to use mutability or not is up to you and depends on what you think is the clearest in that particular situation. Yeah, and some of it's also like not just what's currently the case, but what you're planning, but also kind of knowing what the people and processes in your organization are like. If you're writing Rust code or any programming language, using its features, thinking about the picture of things of as the code gets older and possibly more complicated, or possibly has to interact with new tools and frameworks and things that are coming down the line. There's stuff to think about in terms of, is mutability a good idea? All right, constants. Like immutable variables, constants are values that are bounded to a name and are not allowed to change, but there are a few differences between constants and variables. I think this is a pretty important point. Constants are, in some sense, even a harder guarantee, a more rigorous guarantee of being a particular thing, because you can't even shadow that name. Okay, so first, you aren't allowed to use mute with constants. Sure, constants aren't just immutable by default, they're always immutable. You declare constants using the const keyword instead of the let keyword, and the type of the value must be annotated. I think I'm okay with that because, I guess you could have a lack of annotations if there was like a default type for like a constant int. That might not be so bad, really, but I don't mind the idea that you have to supply the types. I think it's okay. So we'll cover types and type annotations in the next section, data types. So don't worry about the details right now. Just know that you must always annotate the type. Constants can be declared in any scope, including the global scope, which makes them useful for values that many parts of the code need to know about. I still think that you might want to consider some things such as enumerations of going, well, if this is like a member of a canonical set of values, you might want to create an enum. But as far as some especially primitive value of like a number or a particular string or something, I think it's okay to code these constants in. Okay, the last difference is that constants may be set only to a constant expression, not the result of a value that could be computed at runtime. So they're showing this example here of declaring a constant. And I guess the idea here is that these are all defined completely at compile time. There's no input from anywhere other than just the literal code itself, so the compiler can actually do this calculation. So I'm just curious if we hit run on that. And since there's no code in this section, we'll just go cargo new constants anyway, and just see if we get ourselves into trouble by defining that. Let's say we go const 3 hours in seconds, and we're going to say that that's a U32 type, and 60 times 60 times 3. And then we'll throw in here just a print line macro here, and we'll just throw it right inside there. Go cargo run, and that just prints out whatever that value happens to be. Good. And then also, I guess we could try some of the things that it says you can't do, like const mute should give us a compiler error. Rust C const globals can't be mutable, right? Another thing it said is that we have to define the type. Let's see if it enforces that. Missing type for const, yep. So it seems to work the way it said, which is good. All right. So the constant's name is 3 hours and seconds, and its value is set to the result of multiplying 60, the number of seconds in a minute, by 60, the number of minutes in an hour, by 3, the number of hours we want to calculate, we want to count in this program. Actually, I want to quickly hop back to the constant example. What was it I wanted to check? I wanted to check one more thing, which is if I said like let x equal 60, let's say, and let's say trying to be generous to the compiler, I tell it that it's like 32, and then I throw that x in here. Found, okay, so found expected item, keyword let for a full set items. Why wouldn't that be valid syntax? Yeah, there we go. Attempt to use non-constant value in a constant non-constant value. Okay, confusing wording, but it's basically saying what that claim was about, look, you can't stick a variable inside of a constant expression like that. It really has to be constant. Okay. So let's move on to the next little piece here. So Rust's naming convention for constants is to use all uppercase with underscores between words. The compiler is able to evaluate a limited set of operations at compile time, which lets us choose to write out this value in a way that's easier to understand and verify, rather than setting this constant value exactly to 10,800. See the Rust references section on constant evaluation for more information on what operations can be used when declaring constants. We won't dive into that right now, but it's noteworthy. I think at some point maybe we'll go into some of the Rust reference, but not today. Not today. So constants are valid for the entire life, the entire time a program runs within the scope in which they are declared. This property makes constants useful for values in your application domain that multiple parts of the program might need to know about, such as the maximum number of points any player of a game is allowed to earn, or the speed of light. Naming hard-coded values used throughout your program as constants is useful in conveying the meaning of that value to future maintainers of the code. It also helps to have only one place in your code you would need to change if the hard-coded value needed to be updated in the future. That makes sense from a maintainability point of view. Now on to shadowing. So as you saw in the guessing game tutorial in chapter 2, you can declare a new variable with the same name as a previous variable. Rustations say that the first variable is shadowed by the second, which means that the second variable is what the compiler will see when you use the name of the variable. In effect, the second variable overshadows the first, taking any use of the variable name to itself until either itself is shadowed or the scope ends. Nice. We can shadow a variable by using the same variable's name and repeating the use of the let keyword as follows. Let's do it. Let's do it. So we're going to do cargo new, and we'll just call this shadowing. Why not? And this is almost the same example, but that's okay. We'll call that let 5, and then let x equal x plus 1. And then we're going to create one of these local scopes. And inside of it, we'll say let x be bound to the value of x times 2, and print line macro. The value of x in the inner scope is, and then we'll put x. What else did we want to put in here? Oh, and then there's the print line macro at the end there. Print line macro, the value of x is, and then there we are. Let's make things a little bit less confusing on me. Let's also exit out of this and make sure that we're hanging on to the right thing. 0, 1, oh yeah, variables, mutability. Oh, I've nested some things inside of other things that I shouldn't have. Let's move constants out of variable, and let's move variables shadowing also up here. There we go. That should all be at the same top level for us. Good. Better. Now we'll keep our eyes on the right source code. So the first program binds x to a value of 5. Then it creates a new variable x by repeating the x is assigned operation, or is it an operator? I'm not sure what to call it, but using the let x kind of keyword, taking the original value and adding 1 so that and adding 1 so that the value of x is 6. Then, within an inner scope created by the curly brackets, the third let statement also shadows x and creates a new variable multiplying the previous value by 2 to give x a value of 12. When that scope is over, the inner shadowing ends and x returns to being 6. When we run this program, it will output the following. So sure, let's jump into the shadowing and go cargo run. And so the inner scope value is 12, as we just read, and the value of x at the end of the program there is 6, as we expect. Great. So shadowing is different from marking the variable as mute, because we'll get a compile time error if we accidentally try to reassign to this variable without using the let keyword. By using let, we can perform a few transformations on a value, but have the variable be immutable after those transformations have been completed. Bingo. Yeah. The other difference between mute and shadowing is that because we are effectively creating a new variable when we use the let keyword again, we can change the type of that value but reuse the same name. For example, say our program asks a user to show how many spaces they want, but some text by what was I just reading there? We can change the type. Sure. For example, say our program asks a user to show how many spaces they want between some text by inputting space characters, and then we want to store that input as a number. Yeah, sure. So in this example, we've got let spaces is equal to some string literal, and then we've got let spaces again that calculates spaces len, which is going to be some kind of usize, I believe. And that's basically a way of it's a special type of integer for describing, well, the size of data structures. Okay. The first spaces variable is a string type, and the second spaces variable is a numerical type. You know what? Let's do it. Let's do a little bit more shadowing. What should we call this one? I don't know. Cargo new spaces shadow. Oops. It does help to spell stuff. I don't think I can accept that spelling. Nope. Cargo new spaces shadowing. And if I go cargo run, this should just be our hello world script. Let's polish it up with the stuff that we actually want. So spaces, and then I don't know how many spaces are in there. Is it 4 or something? Looks like it could be a 4. And then end the statement, and then let spaces be bound to the value of spaces dot length. So we're getting a warning that we're not using that, but that's okay. And what do I want to do? I guess we'll just run it. Yeah, we'll just run it. Cargo run. And we get those warnings, but technically this is fine. No errors come about. And I have nested my cargo projects again. Whoops, whoops, whoops. Let's bring that out here. Good. Okay, I think we're almost at the end here. The error says we're not allowed to mutate a variable's type. Yeah, okay. Oh, sorry, I jumped a paragraph ahead. Let's go back up here. The first space variable is a string type, and the second spaces variable is a number type. Shadowing thus spares us from having to come up with different names, such as spaces stir and spaces num. Instead, we can reuse the simpler spaces name. However, if we try to use mute for this, as shown, we'll get a compile time error. So here's the difference. In this one, it's let mute spaces. For this one, I think I'll just modify the code that's there. If I said let mute spaces, then we actually have and don't use the let keyword here. Now we've got a problem. Mismatched types expected, reference to stir, or in other words, string literal, and found a usize. Okay. We'll leave it in the form that compiles, or a form that it compiles. Good. Now that we've explored how variables work, let's look at more data types that they can have. Okay, so that's really the end of this section on variables and mutability, and I'll see you in the next video. Take care.